I was thinking about word problems and how word problems and math word problems and science problems go hand in hand. Pretty much all of your science problems are math word problems. But in math word problems or in science problems, they usually give you too much of the information. They give you all of the pieces of the puzzle, and they give you all the numbers, and they say take these numbers and use the equation to solve your problem. Um, and I think that that's good, and it's good in a traditional way. I think that there's merit in that, so we should keep that and not make everything changed. But one of the things I was thinking about is um, forensics chemistry has this really cool project sometimes where you see these really innovative teachers, and what they do is they like make a fake crime scene, and then the students go in and have to take all of the measurements themselves, and then they use all of the equations that they apply, and they actually get to use real data using the measuring tools and all of those kinds of things. How do we address that in a virtual world? Well, the one way I was thinking about is, what if we created a virtual world for the students to go in and manipulate, and they can use this thing called Google SketchUp. So you can, the students can go in, they can manipulate this thing all they want. Um, I have a problem where they're using a Canon, so that's one way. You can make some easy manipulation tabs, and you can go like, if I want to have them look at gravity, or if I want to have them look at the box I was going to have them measure. Um, in my assessment, I'm going to have them basically measure the angle of this rope. Measuring these things is actually pretty straightforward. If I want to measure like maybe the height that the person is, because I want to figure out how much potential energy he possesses, then what I do is I use a kind of a measuring tool like this, and there we go. 2.233 meters, or 2.33 meters. You can have it measure in centimeters. You can measure different pieces like that. You can even measure the angles using the protractor, and you can get the dimensions and all of those kinds of things. And so this gives the students this ability to go in and navigate the problems. And that way, I can even hide some information in there where they need to intuitively figure out what they need to measure so that they can get the problem. The problem that I have set up for this Common Core internal assessment assignment that my curriculum coordinator gave me was, basically I have this guy, and he's on this rope, and he's going to swing, and he is, let's see, before you let go, he's going to kind of swing down and go to about halfway, make the angle about halfway what it is now, and he's going to let go. And then after that, he's going to go into this thing called projectile motion, and basically the guy is going to fall, fall into the water off this cliff and land somewhere over here. Don't worry, he won't land and get killed by the canoe, because the canoe is moving past, but that's for a later problem. He's going to land into the water, so the students have to figure out where exactly he lands in the water. And then in order to do that, they have to take measurements of the height here, and they'll use energy equations to figure out the velocity that he left the rope at, and then based off of those angles and all those kinds of things, the person can calculate the speed, or the distance that he hit the ground at. And I even have a one-dimensional motion problem where as he falls, this canoe is moving, and then the canoe is going to continue to move, and he needs to go and swim after the canoe with an acceleration. So the question is, at what time does he eventually catch the canoe? And so this is kind of my way of doing kind of more of an interactive physics example, where students can go in and manipulate and measure all of these kinds of things.